Okay, so for this question, it says consider the curve given by this equation, and then it states for all points on the curve, dy dx, or the slope, is in this interval. So the slope is always in between 2/3 and 2. That's going to come up handy later, so right now I'll just not worry about it. On part A, they just want us to show that the derivative is equal to 2 divided by 2 minus sine y. So we're going to take the derivative of what we've got. So the first thing I would do is I'm just going to distribute that 2. So I have 2x minus 2y equals 3 plus cosine of y. And I'll take the derivative of each term. Derivative of 2x is 2. 2y would be 2 times dy dx. Derivative of 3 goes away, and derivative of cosine is negative sine y. There's a y, so we have to attach a dy dx. I want to get my dy terms together, so I'm going to go ahead and add this one over. So when I move this one over, I'm going to have to add it. So I'd have 2 equals negative sine y dy dt, and I'm adding over a 2 dy dt. And then I would factor out the dy dt, so 2 equals dy dt times negative sine y plus 2. To get dy dt by itself, I would go ahead and divide, so I'm dividing by the negative sine y plus 2, so negative sine y plus 2. These cancel out, so I end up getting dy dx is equal to 2 divided by, I'm just going to write it, switch the order, so that would be 2 minus sine of y. Well, this is exactly what we were asked to show. So that's part A. Part B tells us that for y in the interval from negative pi halves to pi halves, there is a point on the curve for which the line tangent to the curve has a slope of 1. Once I read slope of 1, that immediately I think, okay, slope is dy dx, so dy dx equals 1. I believe the rubric, you get a point just for writing that. So I know that that's my initial thing. I'm not sure what to do with that y for right now. But if dy dx has to equal 1, they told us dy dx is 2 divided by 2 minus sine y. We need that to equal 1. I'm trying to find the point on the curve where this is true, so I need an x-coordinate and a y-coordinate. So let's see if we can solve this for y. I would times by the denominator, so I'd get multiply it over times 1, just gives us that. I could subtract 2 from each side, so I'd get 0 equals negative sine y. I could divide by a negative, so I just get sine of y equals 0. We need to solve for y. Keeping in mind, so sine of y, sine graph just looks like this. Think of it as like sine x, it doesn't really matter. But y is we're only considering the graph from negative pi halves to positive pi halves. So if we're only looking at this portion of the graph, the only time sine equals 0 would be at 0. So the only time this graph equals 0 is at 0. So sine equals 0 when y equals 0. We're only looking at that interval. So we know the y-coordinate. We now have to find the x-coordinate. So we take this and we plug it back into the original. The original relationship was that 2 times x minus y. And that equals 3 plus cosine of y. We just need to solve for x. So we're plugging in 0 for y. If we plug in 0 for y, we'd have 2x, 3 plus cosine of 0. So 2x equals 3. Let's see, cosine of 0 is 1, so plus 1. So 2x equals 4. Divide by 2, so x equals 2. So when x equals 2, y equals 0. So our point is 2, 0. Because the question said find the point on the curve where the slope equals 1. So we're done. All right, part C wants us to determine concavity for points where y is in between negative pi halves and positive pi halves. So concavity means we need the second derivative. We need to determine if the second derivative is positive or negative. So that's what we're looking for. So I'm going to start with dy dx, and again, it's great. It's good that they gave us what dy dx is. So they told us dy dx is this. We need to take the derivative. I'm going to do quotient rule. So I'm going to find the derivative by doing the bottom times the derivative of the top, which is 0, minus the top, times the derivative of the bottom. Derivative of 2 is 0. Derivative of negative sine would be negative cosine. And then quotient rule, you always divide by the bottom quantity squared. So on top, when I simplify, anything times 0 is 0. So this product is 0. A negative times a negative is positive, so I'd have 2 cosine of y on top. It's now positive, and the denominator is 2 minus sine of y squared. So our goal is to decide if this is positive or negative. So I want to think about whether cosine at y or sine at y is positive or negative. So cosine at y, keeping in mind y is only in between negative pi halves and positive pi halves. Cosine looks like this. Normally I'm only going to pi halves, so it looks like this. So cosine at y could be positive or negative. Oh, I forgot something. Dang it. Okay, I gotta come back and fix this. So before I do this, I need to come back up. When I was doing quotient rule, I did bottom times the derivative of the top minus the top times the derivative of the bottom, but when I did this I had y, so I have to attach a dy dx right here, all over the bottom squared. So now when I simplify, I have, that's 0, so I'd have a positive cosine of y, but then I'm timesing by dy dx. I'm going to go ahead and plug in actually what dy dx is. I'll do that on the next line. So I have to take what dy dx is, which was this, and plug it in to there. So this is equal to cosine of y times 2 over 2 minus sine y, all over 2 minus sine y quantity squared. Okay, so we have to think about whether each one of these pieces is positive or negative. So if I think of cosine of y, I'm only graphing from negative pi halves to positive pi halves. But this graph would be like that. So that's always positive. Then I want to think about sine of y. So sine of y, if I graph sine of y from negative pi halves to positive pi halves, I just know that that's always in between negative 1 and positive 1. So if I am subtracting 1, so when I'm looking at this, so I know this piece is always positive. That's what I figured out here. Then here I need to think about sine of y. The biggest sine could ever be is 1, so when that's 1, I'd have 2 minus 1 on the bottom, so the bottom's always positive, so I'd have positive over positive, so I know that's always positive. Then down here, the biggest sine can be is 1, so 2 minus 1 would be a positive number, plus I'm squaring it, so I know the denominator is positive. So I know on top I have a positive times a positive, so that's positive divided by a positive. So I can just say I know that that's positive. You don't really have to go into your justification, maybe just stating that, sine of y is less than. So if it's positive, that allows us to answer the question, always reread it, determine the concavity. So I would say the curve is concave up because second derivative is positive when y is between negative pi halves and positive pi halves. Okay, and then the last question, part D. Part D gives us the function, says let y be the function defined above, defined implicitly. It's continuous on the closed interval and differentiable on the open interval. Well, that's exactly what has to happen for mean value theorem, and they're stating use mean value theorem on the interval from 2 to 2.1 to show that f at 2.1 minus f at 2 is in between 1/15 and 1/5. So that seems really weird. It's using mean value theorem, but it's putting it on an interval as opposed to saying that like the average rate of change equals the instantaneous rate of change. So I know with mean value theorem I have to find average rate of change. So I'm going to start with that. So average rate of change is just like f of b minus f of a. Now since the interval is 2 to 2.1 and we have 2 and 2.1 here, I'm going to do f at 2.1 minus f at 2 all over 2.1 minus 2. So if we find f at 2.1, we don't actually have to find it because they're leaving it like that. So I'm going to just say f at 2.1 minus f at 2 divided by 2.1 minus 2 is divided by 0.1. So there's our average rate of change. Well, with mean value theorem, we also have to work with instantaneous rate of change. So I want to find the instantaneous rate of change. The issue is it's not just one number. Again, we have it at both endpoints. So I'm going to find the instantaneous rate of change at at each endpoint, at this endpoint and at this endpoint. And my guess is that it's going to come out to be something similar to the two ends. So I want to find f prime at 2. Well, f prime of x is really just dy dx. So I need to evaluate dy dx, which is equal to 2 over 2 minus sine y. When I'm finding this, I'm going to, so I'm not even going to worry about 2 because I don't have an x value to plug in. I'm just going to think about what the instantaneous rate of change could be between. So I know that the instantaneous rate of change is this, and all I know is that sine of y is always in between -1 and +1. So that's how I think I'm going to get these two intervals. So I'm going to say, okay, well, when sine of y equals -1, let's see what the derivative would be. So f prime of x would be 2 over 2 minus, if sine of y is a -1, there'd be a -1. So it would be 2 over 3. What about when sine of y is equal to a +1? So then I'd have f prime of x would equal 2 divided by 2 minus sine of y. I'm going to replace with a 1. So it'd be 2 over 1 or 2. So the instantaneous rate of change has to be, so the instantaneous rate of change is always in between 2/3 and 2. So then I want to take this interval and compare it to that. So the instantaneous rate of change by mean value theorem is equal to the average rate of change. So I'm just going to take the average rate of change and put it right there. So now I could say, okay, 2/3, the average rate of change is f at 2.1 minus f at 2 over 0.1, and this has to be less than 2. I'm going to try to make it look like theirs, which is getting the f at 2.1 minus f at 2 by itself, so I'm going to multiply everything by the 0.1. So if I multiply everything by 0.1, I'd have 2/3 times 0.1 is less than f at 2.1 minus f at 2, which is less than 2 times 0.1. I'm pretty sure this is going to come out to equal this. So let's see, I'd have 2/3 times 1/10, but 2/3 times 1/10, the 2 goes into here, reduces, so yep, there's the 1 over 15, and then f at 2.1 minus f at 2, and then 2 times 0.1, that's 2 times 1/10, and sure enough, that reduces to 1/5. So that is how we can prove this relationship. That's how we can show that that is happening. So this one was definitely one of the hardest mean value theorem questions that I've seen, but it was just having to do it over an interval as opposed to at a specific point. Right, I hope that helps.